Hello and welcome back to another episode of Effective JaRu, the series where we will read effective Java and see if we can port the items over to idiomatic Rust. We are all in enumerations and have been working ourselves through all the examples here right now. It's PayrollDay. Yes, we like that one, I guess. And let's first prepare the environment. Let's have a new file, pay.rs. We can drop everything, then we pull in the module and use the PayrollDay. Pub use PayrollDay that we don't have yet. So let's do it. So let's have a look at the Java version first. So what you see is that the overtime is paid based on the day, but it's actually based on whether or not we are have weekends or not. And there was a version mentioned in the book that basically associated the overtime rate or the overtime computation with the actual day. But in Java, it's kind of difficult to use switch statements and the likes. So it was either very repetitive or ugly or weird to compute that correctly. And if you say repetitive, then it's probably redundant. And if it's redundant, then you risk that on Monday people will earn more because somebody forgot to adjust the computation there. And you ideally, of course, want to have the code that computes overtime rates in exactly one spot and have it in a way that makes it impossible to forget to compute that. So generally, I think having an overtime rate having an overtime rate is really what you want, and I would do it similarly in Rust, just to decouple that, because that's really what this is about. And I think the weekday, the day itself, it doesn't really have any use. The payroll day. I mean, we have Monday. Look, it's not used anywhere. And so I'm not sure if to me this design now kind of fails right away, just because there is no need to have a constant or an enum here that represents a day, because the only thing that is different is of course the pay type, right? I'm not sure. We will implement it anyway and see where we go with that. Of course, we cannot associate data statically with anything in Rust. I mean, we can, but not with an enumeration. So pub enum payroll day, we shall have one, and say Monday and Sunday. I don't want to type all of this, so I just deal with the two cases, maybe Monday, Friday, and Sunday. So we have a good, some spacing there with our standard week. I like Mondays, I like Fridays, and I don't know if I like Sundays so much. Anyway, here we are, and we also need to associate our payroll type. Let's have another enum that is payroll kind. In Rust, it's quite common to not use type, because then you sometimes want to have a variable that is let type be payroll kind, payroll type foo, and you realize that type is actually a preserved keyword, because type is used for type aliasing. So we can't do it. So kind is kind of a good way to work around that, and it's even in a way more precise. I prefer kind over type, because type is something that you use in an object-oriented language or in your programming language of choice, whereas a kind of something is really just something you make up. Anyway, so we have weekday and weekend. That's a good thing. So now we can associate with our payroll day the overtime, the pay type. Yeah, so let's have a function that does that. Pub pay type that, based on ourselves, returns a payroll kind. There we go. And now it's the usual thing, huh? Matching ourselves. Obviously, I'm lazy and I want to use self payroll day. Everything just import it into the main namespace and then the module namespace. So now I can say Monday is yeah, I think I will import the other ones as well. If there's a clash, you will be warned by an error. Payroll kind, bring it in. So Monday is a weekday obviously. Friday is a weekday. So if you do it like this, we can also do it like that. So let's bundle them up, Friday, so that we are not so redundant. And Sunday is a weekend. There we go. So that's implemented. It's exhaustive. It's checked for us. There's no risk of failure on our part here. And yeah, we are good. So now we can implement these guys here, hours per shift. Where is this coming from? Ah, so it's a constant. See, so we can have that as well. Even though we can't have constant in a struct or anything or in an enum. We need to put it on module level. It's private for them, so it shall be private for us. Const hours per shift is a, well, what kind of type do we want to give it? Let's make it a double, because then we don't have to do any type conversions. F64 is 8. Thank you. And now actually we should be able to do all the computation. So pay type, the payroll kind. Oh, sorry, it's not payroll kind. It's actually pay kind. Fine. So now, actually maybe I want to implement it here. Impl pay kind. What do we have? We have overtime pay, which takes hours and the pay rate and returns a value here, which is the payment. Of course, in a real program, you would never use F64 for currencies. You would have a custom type for this to make sure that you don't mess that up ever. So what do we have? If hours are smaller or equal, let's try, no, but if you have an if case here, that's just a short if. So we don't have that in Rust, so we need to do it like that. So if hours is smaller or equal than hours per shift, then, oh yeah, it's the overtime pay. Then it's 0. Otherwise, oh yeah, by the way, it's based on the pay type. Sure, they do it as well as usual with the abstract style. I didn't see that here. I didn't realize it. But sure, we need to make this an instance method. So now on a weekday, we do it like this, right? We take this one, throw it in here. So it's 0 if we have not done any overtime, or it's hours minus hours per shift. So let's compute the extra hours times pay rate by 2, and that is that. Except for some braces that we should put around, and that should be it for the weekday. We are forced to do exhaustive matches here, so let's put the weekend in as well. And here, well, there we don't need braces actually, because it's just hours by pay rate by 2. So that's interesting. So you get like 1.5 or 150% of your payment during the weekend. That's very, very nice. Very, very nice indeed. So what else do we have here? I think that's it, huh? Pay. So the payment, who computes this? The pay type computes the payment. Interesting. So see, once again, pay kind. Yeah. So it's more like a, yeah. I'm not so sure if that design is super suitable. But anyway, we just re-implement the Java version here. So we want another function, fn pay, which has hours worked being an F64 and the pay rate being an F64, returning an F64, and yeah, sure, we are an instance method. So the base pay is hours worked. No. Hours worked times the pay rate. And then we shall compute the overtime. So base plus self overtime pay of the hours worked times the pay rate. And we are done, right? Yeah. Let's be very explicit. And that is it. No explicit returns, at least. So finally, we have a way to, or a chance to use our unit tests here. Test payroll. I don't know why I want to type rule all the time. Payroll testing. Use item 30 PayrollDay. And yeah, I think that's all we need for now. Can we use it? PayrollDay Monday. So that's a unit variant as well. So we can just use it as an instance without really instantiating it, obviously. So what do? We have a pay kind. A pay type. Oh, pay type I called it. It's pay kind, obviously. So get the pay kind of that particular day. And yeah, what's the hours worked? Hours is 9. We have 1 extra hour here. And the rate is 30, whatever that means. And we might want to give it an F64 here so that we know what it is. So we get the pay kind, and then we let it compute the pay. By the way, technically, this is static, it's private, right? And also, now I get it. Okay, so we want to put this up. I didn't see that either. Gee. So yeah, we need to add a forwarder here to make the payroll day a little bit less useless. And it appears that this is a final private field, yeah. So we don't even want to provide that information to the others. Okay, so we don't make this pub. But we have a pay function here that takes the usual things like hours worked, F64, pay rate, F64, returning an F64. Okay, that makes our testing a bit easier because we don't have to jump through so many hoops. So it's self, pay kind, and then we just forward it, right? Hours worked, pay rate, and we are done. That is all. You could argue that possibly, maybe we don't have to separate this, but on the other hand, I think it's a good thing to have. Yeah, let's do that. Good. So now we can basically just remove this step and say hours and rate. Assert equal. I have no idea what that will be. So it's 9 times 30. Yeah, let's see how that works. It will probably tell us that this is not what it expected. But I shall see. Cargo test. Lib. Oh no, cargo test actually test unit. But I didn't like it. If else have incompatible types. Oh yeah, there's a semicolon here. See this? So this basically causes our return type to be unit instead of F64, what we would have expected here. Okay. So the trait mal is not implemented for type F64. Yeah, for the trait F64 with something that is not F64, so that is my bad. As usual. So that will now be inferred, right? But it would have tried to make it an int otherwise. And I think it can infer the rest as well, so we don't have to specify this. Method pay is private. See? That's why we have these integration style unit tests. So left is 285, right is 270. Plus 15. So that's basically the overpay for a Monday and for a Sunday. What is it there? We shall see. 9 times 30 plus 9 times rate by 2. Yeah, obviously you could, yeah, should be the same, huh? But we shall see. Does it work? Yeah, it works. Okay. So that's something I like to do, just put in the formula there instead of the actual number. I don't know what's better. Maybe I'm just too lazy to compute it, which is the actual reason. But it has something, you know, to see what the final computation should be and why this number works. I don't mind. Yeah, so that is that. Abstract methods are used in Java to kind of enforce an implementation of a certain thing. Could be anything, of a certain data that you attach to it, or a certain functionality that you want always to be implemented. Obviously, this forces you to do the same thing for every enumeration variant, right? So you have no way to say, well, we want to share the implementation here, but this is why it was this thing was changed into a kind of subtype in the first place. I think in Rust there wouldn't have been any issue with just having a case that has multiple variants in it, like Monday to Friday you do it like this, and during the weekend you do it like this. This would have been as good, maybe even better, because we don't add this. Yeah, so thinking about it, let's do it that way. Let's get rid of the pay kind, which is actually private. So instead we do this, then the pay shall also be implemented here directly as private function. So self overtime pay, that's still the same, but here we say Monday or Friday. We do that. And Sunday we do that. And that's pretty clear, I think. No need to do anything else there. Yeah, I think that's better. Our test should not be affected by this. Duplicate methods, pay. True. This can now go away. And it's private. And there we go. Nice. So that's better. I think that's the Rust version. It's simpler because you have certain guarantees about your match statement here. You will know that you don't miss a day. If you're afraid of introducing redundancy, or if you would introduce redundancy by a certain implementation or a certain logic, then obviously you would do whatever necessary, maybe split it up into a different pay type, as was done here. But I think in Rust you wouldn't do that in the first place. Well, that is that for item 30, finally. Thanks for watching and have a great day.